Good evening. Can everyone hear me?
Yes,
Fantastic. Thank you. And does everyone see the title slide, Descriptive Statistics?
yes.
Yes, I do.
Okay, great. We can get started. In just a second, let some other folks in. Okay, good evening. Again, I'm Dr. Reggie Taylor from the Office of Research and Doctoral Services. And this evening, I will be facilitating the Descriptive Statistics section. By in the chat there, is it anyone attending here this evening that may have attended last week or one of the previous weeks there? Sessions? Okay, fantastic. Yeah, so we kind of know how this operates. Okay, fantastic, fantastic. That's good. That's good. And how about last week? Were those examples that we used, were those pretty helpful for you in working on your applications if you were taking the course? Fantastic. Okay, well, if that's working for you, just wait till you see what we have tonight, okay? All right, so let's go ahead and get started. Make sure I have the record on, and I do. And okay, so again, I'll do a few housekeeping notes, but all of you that attended last week, you know our main goal is to ease anxiety, okay? And once we ease that anxiety and we're kind of comfortable looking at the software and kind of have a good overview of what we're doing and why we're trying to do that, then the rest becomes a lot easier because you're focusing your cognitive energy on your task and it's not being eaten up by a lot of anxiety. So pardon me, but that's the psychologist in me, okay? And what we're going to focus on, there's a discussion going on in the research courses this week, and we're going to take a look at that. But then remember last week and any other weeks, how important I emphasize the four scales of measurement are, because they pretty much determine what you can, what you cannot do, the types of things you can do, the types of things you cannot do. And I think that everyone understands that. So again, we're back in that same boat. When we start running descriptive statistics, we need to understand the scales of measurement, okay? Then I'll give you a discussion exemplar. We'll take a look at it, but then that will also be placed in the chat for you, just as we always do, that along with the presentation. You know, we'll take that live look into SPSS, and you know I always have some quantitative resources available. I believe I have a knowledge check for this course and a survey that I really, really, really appreciate that you would take a few moments to complete, okay? So as far as housekeeping, this is a 1-hour session. I really try to keep it within that time frame. I'm very cognizant of people's time, and time is valuable. The session is recorded and should be available within 24 hours, okay? It will definitely be available here on this my YouTube page, okay? So you can check there first. And then hopefully sometime tomorrow, later on tomorrow evening, you can go to the ORG's website that I always point you to, where you can see the list of on-demand resources. As always, you know, we keep a courteous environment. So therefore, please mute your line unless you're speaking. And my responsibilities to you are to provide you a safe, friendly, and non-intimidating learning experience, okay? And I hold that to be very, very dear to my heart, okay? Now, having said that, this is not a general statistics seminar, nor is it a complaint session. So therefore, you know, we can't focus on those other types of things in statistics that we can't, you know, really address in this amount of time, okay? And we're going to focus on the abstract and pretty much hoping you get through this week's statistics application that you may have to do. Again, the survey and the knowledge check will be available. Now, remember last week, we all started out here on the left with that look on our faces, and we ended up hopefully looking like the little caricature on the right. And that's always our goal, where we're trying to get you from here to here, okay? Now, very briefly, because you have many resources on this, here's a very in-depth scales of measurement tutorial. But we have 4 scales: nominal, ordinal, interval, and ratio. That's what the NOIR stands for. Remember categorical data, such as gender, male, female, and we're limited to the types of mathematics and the type of analyses we can do with that data. But we can still do things with it. Ordinal, we kind of go up a little bit in order, and but it's ranking information. Everyone on this call has probably completed some type of a Likert scale before. Are you satisfied, very satisfied, et cetera, going from 1 to something. That's ordinal. Interval are the true numbers, but we have no zero value. In other words, if you're measuring something such as weather, when you got to say 0 degrees, that doesn't mean that weather doesn't exist. It just simply means that, it's so very cold outside. And then the highest form of measurement, ratio, true zero value, and we can do a lot of mathematics, a lot of different analyses, and a lot of different things with that data. But again, you can look in depth at the scales of measurement video tutorial, okay? Now, when we talk about descriptives, we pretty much have 2 major types. And you've probably heard the terms descriptive and inferential statistics. The descriptive statistics is where we describe data, we organize it, we summarize it. Last week, when we did the graphical display of data, we were providing descriptive statistics, but we were presenting it in graphical format. Remember, we made the pie graphs, we made the bar charts. That's describing the data, but we did it with graphs, okay? But we can also describe data with numbers, okay? And we'll focus a lot more on the numbers tonight versus the graphs. So basically, the last 2 weeks have been descriptive statistics, but we first learned to understand them and how to present them with graphical depictions. Now we're going to learn to look at numbers and kind of understand and be able to describe data, okay? On the other hand, the inferential statistics are when we are testing hypotheses, and you will be advancing into that, running specific statistical tests. But you'll see just how well this foundation that we have placed will really help you understand moving forward, okay? Now, let's talk about descriptive statistics. What are they? Well, one of the descriptive statistics that we can talk about is something called measures of central tendency. And just look at the words, central tendency. And what that means is that the data, how does the data, if I would describe the data, and let's say I come up with an average score, well, how do the other pieces of data fit around that average score? Say, for example, 10, this average in the middle here is 10. But all these little dots represent the other data points, but the average value is 10. So some would be less than 10, some would be more than 10, etc. But we want to describe the data in terms of how well it tends to gather around that central point. That's the focus of central tendency. Okay, is everybody okay with that? Now, having said that, how do we measure central tendency? Well, probably perhaps the most well understood measure is the average. The average score on something. But let's talk about the scales of measurement. Obviously, we cannot calculate an average if we don't have numbers, right? So therefore, if we had a nominal variable, remember categorical, we can't calculate the average of man and woman. It's no such thing. It doesn't make sense. So that's why the scales of measurement is important. So when we want to calculate the average, it's just simply adding up the numbers. Here I have 3 numbers, 11, 9, and 10. I divide them by 3, and they come to 10. So that's 30 divided by 3 is 10. It's simple. That's the average. But when do we use the average to describe data? We use the average when the data is pretty much a normal distribution. That's when the mean or the average is the best depiction of central tendency for a continuous variable, okay? But how many times have you went perhaps maybe house hunting or job hunting or anything, and you hear the words, the median income. Not the mean, but the median. What does that mean? The median house value. You move into a neighborhood, they tell you the median cost is this. That's not very helpful. Why? But first of all, we use it with continuous data, but it's more of a position versus a value. For example, in this data set here, I have 6 numbers, 3, 4, 7, 9, and 179. Do you see how far apart 179 is from these other numbers? It would definitely skew the average. So what we have to do, say the best way to describe that type of data is what we call a median, meaning the middle position. So the median value here is 7. But as you can see, we don't know what the extreme can be. I'm sorry, let me go back to that. We don't know what the extreme could be because all we're going to do is take all of our numbers, line them up in sequential order, and just pick the middle one. Does everybody understand that? That's the median. Now, you will use that when you have extreme outliers or what we would call non-normal data. Okay? Remember, the mean, we got normal data. The median is non-normal. So again, the next time you hear something about what is the median, you know that that's not the average, and perhaps that's not the best depiction of the data, but that's what we have to use for a median. Now, finally, we have a measure of central tendency, and it's called the mode. The mode is simply the value that occurs the most in a distribution. 2s only showed up 2 times. 4s only showed up 3 times. 5 only showed up once. 8 showed up 5 times. That's the mode. The most frequent value. Is everybody okay at this point? So what we're going to determine is how to run measures of central tendency, again, based on the scale of measurement of the data, okay? And those are the measures of central tendency. And notice that I have the arrows pointing in, meaning how does the data tend to converge toward the center? Remember, center, central. How well does the data fit around that central point? That's what you're trying to understand in the way that you can describe data. Now, but we know we have not only measures of central tendency, but we also have something called a measure of variability. What we're doing is exactly the opposite. We are trying to measure and describe the data in terms of how it disperses away. You see the arrows away from a central point. Okay? How much does it vary from this central point where in the previous slide, we were looking to see how well the data converged around that center point. Okay, those are the measures of variability. Now, what are those measures and how do we apply them to our scales of measurement? Okay, so let's take a look at the range. Now, the range is also something that we can use for continuous data, okay? The range is simply the distance between the highest and the lowest values, okay? So, for example, look at this third line here. Now, you see I have a lot of data, and it's not in any order, but we could clearly see that the lowest value is 6, and the highest value is 32. We simply do the mathematics and do the subtraction, and we have a range of 26. That is a measure of variability also. So as you can see, you have choices of measures of variability, measures of central tendency. You just have to determine which one is the best and most appropriate to use for my data. Okay? Now, we also now are going to take a look at the bell curve so that we can understand a little bit now of what we're talking about. And this is a very important concept in statistics here. You always hear the bell curve, the bell curve. You always hear terms of standard deviations, standard deviations. What does that mean? Here, the bell curve is really something that we call a phenomenon, a statistical phenomenon, meaning that in life, in real life, we have found that in most cases, no matter what we're measuring, IQ, if we're measuring your GPA scores, if we're measuring your self-esteem, anything we measure, the typical human being is going to fall somewhere between minus and plus 3 standard deviations from the mean. Now, here's the average score right here, okay? Let's just say this average score is 42. That means that now, if it deviates, remember, this is a measure of deviation. If it deviates by 2 points, that means that one standard deviation, we go down 2 points, so we go to 40. You see, 42 minus 2 is 40, but 42 plus 2 is 44. So as you can see now, within one standard deviation, right here, the blue line, that 68% of the people will fall in that blue category. That's what that means. If I were to randomly go into Walden's database and pull student GPAs randomly, select a certain number of them, 68% of the people will fall within one standard deviation. It's just a statistical phenomenon. Now, then suppose you're 2 standard deviations away. Well, that's 4 points, because remember, one standard deviation is 2 points. 2 standard deviations would be 4 points. So as you can see, the range kind of gets a little wider now. So we go to 38 to 46. And what happens is that 95% of us, let me clear this up here. Now, 95% of us will fall within, let me draw that, will fall now within 2 standard deviations, the green. See that? The green. So 95, almost all of us are going to fall somewhere in here. But now, we have those exceptions. And if you were like me in high school, you would probably be minus 3 standard deviations. I didn't do well. I didn't like school. I didn't want to go to school. So my GPA was low, but really way outside of the standard deviations. I was an outlier. You see that? But suppose you have that 4.5 GPA. You're an outlier on this end. You're greater than 3 standard deviations. But that's just the concept of the bell curve. And then what we're trying to do is explain data in terms of how it aligns with the bell curve. Does that make sense? You don't really need to remember this 68, 95, et cetera, and all that. But the majority, 68% of people, will fall within one standard deviation. Now, these standard deviations will change depending on the data. The average may be something else. The standard deviation will be something else. But it means the same thing. That's the concept of the bell curve. So when you are hearing something about you have outliers in your data, that means that that data has fell outside of plus or minus 3 standard deviations from the average score. You're way away from that average score, either on the left end or the right end. And that usually constitutes an outlier in any data set, okay? So now, having said that, I wanted to show you how we can describe the data now in terms of a normal distribution. Right here in the middle is what I just showed you. excuse me, the normal distribution where the mean is right here in the middle. But with a normal distribution, the mean, the median, and the mode, believe it or not, are all the same. Okay? Now, but most data is not going to look exactly like a bell curve. It can be skewed. Have you heard the term skew before in statistics? If you have, what that means that the data is going one way either here. Let me make sure I have a good pen for you. You see how this data is curving and going here? More of it is here. If this is if this is the average score right here, you see how few data points are over here? Most of the data points are higher than the average. So if data is negatively skewed, that means that, let's say we took a test. That means that everybody did well on that test. You see what I'm saying? Because if the average score was here and most of the people are here, then you did well. But now suppose conversely, the data is negatively skewed, but suppose it's positively skewed. What that means is that, again, let's look at the average right here. Most of the scores are over here, you see? Meaning we didn't do too well on the test as a whole. A few of us did greater than the mean, which is, going to the right, but the majority of us are over here. So if we look at that from a conceptual standpoint, what it simply means, and I have a better look here for you, if we were to plot a graph, we have the average score right here. It's not down the middle, but it's right here. But as you can see, that most of the scores, because this is the frequency here, how many times it occurred. A lot of the high numbers, how many times, is over here to the right. Okay? Is over here to the right. Few scores are on the lower end, because this is frequencies again. So 10, these are low numbers. So the number of responses are on the low end. So that means, again, few scores on the low end, majority of the scores on the higher end, because these are the higher numbers here. And again, that just means the overall sample reported higher measures of self-esteem. So it's just a matter of looking at graphs and trying to understand, what they are telling you. But it's important to have that frame of reference that we are comparing everything to the normal distribution. And then data can either skew left, it can skew right, et cetera, et cetera. Does that make sense? Okay, now, but you don't really need to worry and remember this, because now SPSS is going to give us reports that tell us these values and let us know, is the data good, is it bad, is it non-normal to the point where it's been violated, all those types of things. But this is to give you that foundation to understand when we run SPSS and look at the outputs, what it means, okay? Now, the other thing that you can look at is something they call kurtosis, which is the shape of the data, not the spread, but the shape. Is it high? Is over here on the left? Does it have a high peak? Medium peak, or even here what we would call a flat peak? And that's something called kurtosis. Don't try to remember that, but there are values to evaluate that. And we're going to look at an SPSS output and be able to tell, has kurtosis been violated? Is it a problem? Okay. Now, here's the beauty. Please, everyone, open your eyes if they've been closed. This is what we have to do. Right? This is what we have to do by day 3. Now, look at this. Remember scales of measurement? How important I say they are? By day 3, you're going to do something for a continuous variable and something for a categorical variable. So do you see, first of all, how the scale of measurement still is lending itself to us needing to understand that? Now, let's take care of this one. You are going to know how to run this report here on the right. Don't worry about that. We'll get to that. This will give you the answers to your questions. Report the mean, median, and mode. There it is. The mean score was 26.73. The median was 26. The mode was 25. There it is. You simply type in the numbers. Everybody okay with that? Do you understand that? Okay. But now we know what these things are too, if we want to talk about them, right? What value occurred most in this data set? Please type it in if you want to take a chance at it. Which value occurred most in this data set? We had 433 records, which 25 exactly, the modal value. Now, what might be a better measure for central tendency? The mean, the median, or the mode? We'll be able to answer that question, okay? Report the standard deviation. There it is. We'll be able to talk about how variable are the data. That's the variance. How would you describe this data? We're going to talk about that in just a second. And what sort of question, blah, blah, blah. Now, the next thing we'll do is take a look at the next slide, where we have to address the categorical data, okay? But first, let's answer the question for our first assignment. You're going to get an exemplar that looks just like this. Remember the exemplars I gave you last week? You're going to get something very similar. For your continuous, remember, I'm just answering this question. What is the mean, median, and mode? You simply say the mean was 20, whatever that output that we're going to receive is. The numbers are going to be there. Remember, it's going to come right from this SPSS output. Here's the mean, median, and mode. Okay? Now, the next thing, what might be the better measure for central tendency? We are going to have to run something to really understand that, but based on a histogram, we're going to run these histograms and look at the skewness, et cetera. But remember we went to skewness and we said we were talking about acceptable values. You see the acceptable value, excuse me, the skewness is negative to a positive 3. Remember that now, negative to positive 3. Take a look at this, okay? I'm sorry. Where is it at? Give me a second. Is skewness a problem? No, it's fitting right inside. It's not greater than 3. It's not less than 3. So skewness is not a problem. And as Demisu indicated, the mean is probably the best measurement because the data is normal. In other words, somewhat normal within the range. Does everybody see that? That's how we're making that decision. Because we know we have a threshold, -3 to +3. We simply are going to look at the value to see, have we exceeded that value? If not, the distribution is probably a normal distribution. And what do we run for the normal distribution? We report the mean. You see that? Now, perhaps if we had a lot of skewness, data was really, really bad, we would probably then say perhaps the median might be the best. Do you see what I'm saying here? How to understand how the distribution looks to determine what's the best measurement. That's what we're doing here. Okay? Now, let's take a look at a categorical variable. We know that this is that nominal variable. Remember, male, female, something that we measured that was categorical. Now, in this case, I don't know if you remember from last week that we looked at the source of stress as a variable. Remember, it's categorical because we had 9 categories. The work was a stress, or the spouse, or the relationships, etc. So this is categorical. It's no number. We didn't measure anything. And we just said how many said work is the problem of their stress. How many? So we categorize them. So for a categorical variable, we report, and it tells you to run a frequency distribution in your assignment. You see here, a frequency distribution. This is a frequency distribution, and here it is. And now we understand. Now, let me ask you the question here. Looking at this, what is the mode? What would the mode be for the sources of stress? The mode would be the response that occurred the most, work. 224 people reported work as their source of stress. Remember, the mode is the value that occurs the most. So that's the mode. And yes, Karen, the mode is the most frequent, but it may not be the best. And mainly if the data is not normal, the mode may be the best. But if it's normal, then it would probably be the mean. So does everybody see that? Now, an appropriate measure of variation. Here we go. The mode is the most appropriate because that's what we use for a nominal variable. You're just simply saying, I know I use the mode when I have a categorical variable. That's all this is asking you. Does everybody see that? Yes, your data is going to come from data sets. We're just learning what you'll do when you actually get to the data set. Yes. Now, remember what I said here? I say a nominal variable is the lowest measurement scale and does not allow mathematical calculations. So in this case, the work is the modal category with 224 responses. You word that as you want to. And again, this will differ based on the data that you look at, but you'll understand exactly what you're looking for. Now we also asked how variable are the data. Again, I just put the mode there, the range. The range is from 16 responses to 224, 16 on the lowest end. But you can report that other ways with the variance, but we'll get into that. Now you're simply here going to describe the data. How would you describe this data? You're going to put all this information together. So let's read this here. I'm sorry. The data, the source of stress comprised 9 stress categories because my frequency distribution told me it's 9 of my count them. Okay. Most respondents identified work and finances as the primary sources of their stress, okay? Because work was 224 and finances was 54. So I just took the 2 highest ones and said the majority of them, said these 2 categories. You can describe this differently, but you understand what you're describing or not. Then I said, and I just said their primary source is just 51 and 12% respectively. And then work was the modal category with 224 responses. At the same time, the time right here, the last one, was reported the least. All you're doing is just telling me what this frequency distribution is telling you. You see that? That's all you are doing, is telling me what the frequency distribution is telling you. And that's all it's telling you. So don't try to go out there and write a book because, it's like they give you a rope and you hang yourself. All you're trying to do is just answer these questions. Okay? Now, again, how would you describe it? You describe that frequency distribution, and then what sort of research question would, you ask? You can come up with anything. But of course, the variable source of stress needs to be in the research question. Okay? And I just said, is there a relationship between the source of stress and I just said total perceived stress or something of that nature. You probably want to look at a variable in the data set that you use, okay? That's pretty much the assignment. Now, the beauty is that I'm going to give you an exemplar to use. So why don't we first, let me do that. Let's take a look. No, let's stay in the presentation first. Now, how do we do it? We got to do something for a continuous variable. Let's look at that first. You'll have this presentation. You'll have the recording. Again, remember in SPSS, I'm using version 29. If you have a different version, you may see some things that look differently. If you have 28, 27, but again, the concept is the same. Analyze. We're doing descriptive statistics. We want frequencies right here, okay? And then we'll click on statistics. That will pop up the statistic box where we tell it we want the mean, the median, and the modes. We select that. That's what's going to print on that output that we're going to use to fill in our responses. Does everybody see that? You see, you even get the skewness and the kurtosis all in the same run. You get the standard deviation, you get everything. Remember, we were looking at measures of, let me show you this. Remember, we were looking at measures of what? Central tendency. And what does this say? Central tendency. And we were looking for measures of dispersion. There they are. Okay? When you hit continue, you'll get your output. And this is what you'll get. This is just what we looked at in the previous slide. Okay? Does that make sense to everybody? And then when it asks you in that assignment, what's your mean, median, and modes, you're going to report those values and whatever else, it asks you to do. Does that make sense? Everybody okay? And see where you're trying to get. Fantastic. Now, we also have to do that for a categorical verb. Let's see, excuse me, what's that one? Again, here's the frequency distribution that's created. And give a second here. I'm sorry, we're getting ahead of ourselves here. Okay, I'll tell you what, let's get into SPSS now. That's a bit, but the first thing I'm going to do is I'm going to give you the example. I want you to see that because I want to see those smiles come on the face now. Okay, and I'm going to take the, where shall it be? Give me just a second. This is what you're going to get. And we're going to put this in the screen before we move forward. Okay. Does everybody see that? The Walden University statistics page exemplary? Yes. Okay, great. So again, this is it. I just got some little notes here, how to get in touch with me. But again, that's your continuous variable. And it's set for your continuous variable. You see that? All you're going to do is just follow this format. You have the information for SPSS, how to get the 2 reports you need. And you kind of understand now, we start with a normal distribution, but now we're trying to explain the data, how it kind of deviates from this or that, okay? Now, notice in here case, I give the acceptable ranges because we know, between plus and minus some values. And I even state here, skewness value between plus and minus 3 indicates an acceptable range. I'm just showing that I understand what I'm doing here, okay? Report the standard deviation right from the data set, right from that report. The same things we did. Now, let's just take a look. Here it is for the categorical variable. Remember, you have to produce the frequency distribution. Here it is. And these are the answers to the questions. Okay? Does that make sense? Now, what we'll do is just kind of reinforce our learning here. And let's look at SPSS here. Okay? Just bear with me. I have so much stuff open for you guys here. Now you should hopefully see the SPSS screen. And remember, we had the analyze, we went right here, descriptive statistics, and we did frequencies. I'm live in SPSS now. And as you can see, say I want total perceived stress or whatever variable. But remember, you have to select a continuous variable. If you select gender or something like that with the little circles, that's the wrong scale of measurement. Select something that has the little ruler, the scale. And we also know how to look in the data set. We'll get there in just a second. And then, my friends, as you can see, there's everything that we need to ask for. Okay? Variance, anything, your kurtosis, everything. We hit continue, we hit OK. Remember, that's it. Okay? Now, all I did was, again, you may have a PC, you may have a Windows, I don't know. Your mouse may be set up a certain way, but you would simply copy, and then you would go into a Word document and paste it. Okay? And that's what we are forced, we're doing this week. So now let me, let's take a look at the data set, because this is, again, where we just want to make sure we're pretty comfortable in understanding the data. Now, remember that what's important to understand is that all-important scale of measurement. So when you open up the data set that you're going to use, you have to have a scale variable. So, for example, if you open up a data set and it had stress in it and you saw that it was scale, you know that you can run the descriptive statistics for the scale variable. Okay? If you want the nominal variable, make sure that you know that the nominal variable is the variable that you are selecting. Then you just follow the two procedures that we did and that we showed. Does this make sense? Everybody feeling a little bit of anxiety kind of going down now? Okay. Now, again, just to give you a little bit more help, remember now, we're in the variable view. And what I'm doing is looking at the variables and how it's made up. There's no data in this view here, no data whatsoever. But I know my data file, I have a variable called stress. It's a scale variable, etc. Here I have something called gender, but it's nominal. Remember, from nominal variables, we have to have a values column. And we see here that for our gender, that we have two categories, male and females, okay? Remember that. Let's look at another categorical variable, child. I don't know what they were asking. I guess, do you have children or not? Let's see. You see, yes or no. These are categorical responses. So remember, for the categorical variables, you want to make sure you get the nominal. And for the continuous variable, you make sure you select, a scale variable. Okay? Now, when we go to the data view, here are the responses. Gender. You notice now that we don't see labels, male or female. We see twos and ones, but we know that's the categories, how it was coded. So from the data view, if we didn't want to go into the variable view to see what 1 and 2 represents, remember, we always click on the alphanumeric, and look what it does. It gives us all the text. And then we can go back to see how it was coded. You see? So again, just to reinforce SPS, just to ease that anxiety and to get you comfortable looking at it and saying, this is not as foreign to me as it was hopefully an hour ago or last week or 2 weeks ago. And the more you open up files and we reinforce this, the anxiety should start going down and you should start feeling a lot better. But having taught this for over 20 plus years, the biggest mistakes I've seen ever made is not understanding that relationship between the scales of measurement and whatever else it is you're going to do in statistics. Does that make sense? That scales of measurement, if you know that, that will get you through a whole lot. Because if you select the wrong scale of measurement, you're just wrong. There's no correct response in that document you're going to send me, except that you did the wrong variable. Please redo this and do a continuous or whatever the case may be. Okay, but you don't want to have to go through that. Okay. Now, let's get back to PowerPoint here. And let me make sure we get through the entire presentation. Now, and again, remember, here you'll get your frequency distribution and all that information. But the next thing I wanted to show you, again, remember the resources. Here are the resources that if you click on this link, okay, what this is going to do is take you out to the Walden Research Center website, okay? And remember, last week we did this, right? Visual displays of data. If you click here, you'll get to that link and you'll be able to revisit that information. And tonight, here we are, Descriptive Statistics. Okay, you registered here. This will move down to here by tomorrow, where you'll have the presentation, okay, the recording to use for your application assignments. And then hopefully you've registered. But tomorrow night, where we'll help you with the statistical significant effect size, and you have something to do on confidence intervals, I think, coming up in another week or so. So I'm trying to get it way ahead of time now to prepare you, take some time to look at the presentations, the slides, and get your thoughts together and things of that nature. But those are the resources that you'll be going to be pointed to. Okay, remember scales of measurement back here. Look at that. Back in 2014, I did this because it was just so important. So important. And this scales of measurement doesn't change. This will be very helpful to you, okay? And then once we start getting into our statistical tests that we'll be doing, you'll see that I have seminars for these already recorded, but we will do these live also, okay? We'll have the live interaction here. And so it'll just be repeated. You can also, if you go out here, there's a knowledge check if you want to just say practice and answer 4 or 5 questions about descriptive statistics. And then finally, I would greatly appreciate you going out here and completing the survey that helps me determine, what your needs are, what I can do, what I cannot do for you. And as you can see, it takes about 10 minutes to complete. And really where you help me at is when you give me this narrative information. And I can know what we're doing right, what we're doing wrong, what you want more of. Is it working? Is this okay? Is it great? I need to know. I don't just regurgitate information to you. I believe in you telling me what it is that you need. Okay? So if you don't do that, then I'm going to give you what I think you need. So you probably want to tell me what you need, what you thought about this, et cetera, et cetera. Okay? So now, let me now take the presentation and let me get that into the chat for you, okay? So if I go into the chat here, I didn't put anything in the chat yet. I didn't put the exemplar in there. Okay, let's get those documents in there for you now, okay? So you should check now. You should see the exemplar. It's a PDF file. Yes. I want to make sure everyone can see that. Does everyone see that? And if you go to the bottom of it, fantastic. And now we'll put the presentation in there. And so again, all those links will be in the presentation, okay? Now, if you don't see it, I don't know what the issue can be there. I couldn't really tell you what the issue could be, but they're in there. So I'm not quite sure why you don't see them. Let me put them in there again. Hold on a second, though. Hold on. Let me put them in there again. Okay, give me just a second. What's that? Okay, yeah, I know what's going on. Give me a second here. Here's the exemplar again, and everyone should see it this time. And here is the presentation again. Okay. What's happening is that check when you send a chat, there's a to box there, and you're sending it to me. And when I respond, it's going back to only you. So unless it's private, you can send it, make sure you say to everyone, okay, in the meeting, and then everyone will get it. So I was responding to just some individuals that said they needed the presentation. So everyone should have it now, everybody, okay? And that's it. I think if you go through the recording and kind of go through the presentation, open up that data set, find you one categorical variable, one continuous variable, and follow the steps in the process. And I think you'll be good to go for another week. Now, what we've done here so far is we've hopefully, and I would at least like to see a yes or a no, a thumbs up, have we eased anxiety? And if we haven't, please say no, but have we somewhat lowered that anxiety level about what you'll be getting ready to be faced with? Okay, so yes, a little bit, and that's it. We're just trying to lower it a little bit. Okay, fantastic. And again, you have these things to look over and over and over again, okay? Over and over again. Remember, we talked about that discussion that you're going to have to do, and we've actually done that. Again, please remember the 4 scales of measurement, how important those are, okay, in everything you do. We know we can describe data in terms of how it diverges on or converges on a central point. And we can also talk about data as how it varies from a central point. And we also know that we can also look at the shape of it, and that's the kurtosis. But anyway, you have, the exemplar to use, okay? And here are the links again to all those resources on this last slide here. So again, and you could have done too much. That's between you and your professor there. But again, the main gist is that you understand what to do. Now, how much you do and don't do, that's up to you. But again, sometimes too much is not too much. It just depends on how much the professor wants to read. I want you to give me just what I asked for. I don't want to read a whole lot of other stuff, There'll be enough time for you to give me a whole lot of writing, if I were to become a committee member for you or your dissertation chair. So trust me, there is going to become time for you to provide a lot. Right now, you don't need to, okay? Now, Melanie, you asked a very good question. If the age are in a group, do you still calculate the mean? You can. That's a good question. Now, let me show you something here about SPSS. Very good question. If I can get into it here, let me. SPSS, yeah. Come on, SPSS, show up. There we go. You see here, education, that's an ordinal variable, and that's kind of like that order ranking you're talking about. Can I use that as categorical? Yes, you can. But you have to operationalize it as a categorical variable. So, okay, what's the question again? Let me make sure I don't misspeak here. Let me get back to the chat. I got a lot of bars open here. So the question was, okay, if the age are in a group, okay. If age is in a group and you want to use it as a grouping variable, you want to make sure that it's, give me a second here. Where's age? Okay, see now age is not in a group here, it's numerical. Okay, you see the little arrow. But if age was in a group, all you would simply do is, it's just like this would be an ordinal variable, but you have to go to the variable view and you can take an ordinal scale, like education. And if you want to look at it in terms of highest to lowest, you can. And that's ordinal, a lower ranking going up to a higher ranking. And that higher will be, as all of you will be here soon, postgraduate completed or PhD. You started out very low and we go in a ranking order. But I can also say I want to operationalize this as a categorical variable and just put you in categories. All I simply need to do is just change it to a nominal variable. But if I have it as excuse me. As an ordinal, I can still calculate an average to answer your question. Yes, because now I'm using it as a number, but not a category. You see what I'm saying? So yes, so it depends on, again, the scales of measurement are very important. So if age is a group, you can't, but if age is ordinal, you can do mathematics. Remember, as we go from different levels, nominal, ordinal, interval, and ratio, it allows us to do more and more mathematics with it. So if we made it nominal, less mathematics. We made it ordinal, a little bit more mathematics. Okay, so that ordinal can be operationalized. In other words, when I say operationalized, I mean, how are you intending to use it? Okay, as an ordinal variable or as a categorical one. And that's your choice. And there's a lot of decision points to that. But to answer your question, I hope that answers your question in there. Does that help a bit there? Did I make sense? Okay. All righty. Well, other than that, I don't have anything else. I really hope, again, that we're on the right track, and this is kind of suiting your needs, and kind of helping you get through this process. That's my hope. Okay. Again, I'm not your faculty. I'm not in your classrooms with you. If I was, this is what we'd be doing. But again, hopefully you understand, a little bit more now about reading an application and understanding what I need to do. Because half the time it takes a whole week to read it to try to even understand what am I trying to do here. So hopefully this will help you understand. I'm getting ready to describe some data. And I know that I have continuous data and I have categorical data. And I know that there are different descriptions for each type. That's the broad concept I want you to understand. You'll be able to click the buttons and SPSS is going to do all the hard work for you. You need to have a conceptual understanding, okay? At a dissertation defense, I'm going to ask you to tell me what is meant by skewness. You're not just going to read your slide and, oh, I did this test and that test. I'm going to say, okay, what do you mean by skewness? And now you don't have to sit there, no, you know what you're talking about. That's what I want you to know, what this stuff means. That's the important thing. You don't have to be a statistician to tell me what a mode is. You don't have to be a statistician to explain what a mean is. You don't need to be a statistician to tell me when a median should be used versus a mean. You need to understand the concept. That's more important to me than anything else. Okay? So my friends, once again, until we meet again, which again, I'm gonna be tomorrow, I guess. Thank you. Thank you. Thank you. And take a moment to complete the survey. If you feel up to it, it's anonymous, it's voluntary, but again, good luck. And as I mentioned last week, reach out to me and let me know how you did. Okay? We can see if we're making that progress. And again, getting from here to here. Okay? So I'll leave the classroom open for a few minutes in case anyone didn't get any of the documents out of there. I wanted to revisit any of the chat. But again, have a blessed evening, and I hope to see you tomorrow evening. Okay? Bye-bye.